To ja. Awesome. So let's start. Welcome, everybody. This talk, despite its name, Advanced Opentelemetry Magick, will definitely cover some of the basic concepts of Opentelemetry. If you've been to DevOps Days there in Krakow or Warsaw, you might have seen my lightning talk on precisely the same topic. At some point, I just figured I'll just put it into bigger presentation because as far as I saw, very often people wouldn't even know what it is, like what are the basic concepts and basic entities in Opentelemetry at all. Just a quick intro about me. Currently, I'm working as an engineering manager at Clary, and I run the entire SRE org, well, for that company. So, what is this presentation going to be about? Factorio. Have you played Factorio? Everybody who played Factorio? Yes. Oh my goodness, you nerds. I've spent like hundreds of hours in that game. But I actually find the... I know, right? If you think about it, like it's really nice to think of in terms of Factorio when you're looking at all the pipelines and all the entities in Opentelemetry. And we'll be discussing both the stuff that is on the belts and the stuff that kind of assembles stuff to the next level so that you can build your rocket. So I'm going to cover Opentelemetry, I'm going to cover Opentelemetry data model, and I think this is kind of the most crucial part to understand, like when you think what's flowing through your pipelines, so that you know how it's built internally, because it's mapping pretty well between the config, when you do configure your collector, and the internal data model, how it is actually being represented in the code, and how to get creative with Opentelemetry. What I am not going to cover is, it's not a sales pitch. So a lot of the times when you have a discussion on Opentelemetry in conferences like this, there are companies that are actually selling you observability stuff. I no longer work for observability company. I am just a fanboy, like a proper fanboy. If Opentelemetry had OnlyFans, I would subscribe. So I will not tell you what platform to pick, because I can bitch about pretty much every major platform there is currently. There is always something with a lot of them. There is Datadog with unpredictable invoices. Don't get me started. And I won't teach you anything about illegal Lego building techniques. I learned about it. I had no idea it exists. Google it. It's crazy. Anyway, just to explain some terms, observability, or OLI as it is sometimes called, is kind of your ability to figure out what's happening inside your production stack based on everything that it's emitting. It actually comes from control theory, I believe, but like whatever vendor you're asking what it is, they will just give you completely different explanation. So what's observability? I don't know. I'm just collecting metrics and traces and whatever there is, trying to figure out what the hell is running in my app. Opentelemetry, it's actually pretty great because like if you go back like 10 years ago, we had numerous competing standards here and there. We had a lot of proprietary protocols, like if you run Datadog, they had their own way of sending telemetry. SignalFX and Splunk, their own way. There was Grafana, there was like open sensors, open tracing. At some point, somebody figured out, let's make a standard, right? What can go wrong? Only this time, it actually did work remarkably well. Currently, most of the Opentelemetry is stable. There are some parts which are still in beta, but they're functioning pretty well. So yes, I think like most of the platforms that I had the pleasure to talk to recently say that they do support Opentelemetry. I don't know how basic you are in terms of observability in itself, but like very quickly, what is metric? Like you have stuff that is telling you what is the current state of a thing, and it has an associated timestamp. Like this is the most basic thing about the metric. What's my CPU? What's my disk usage? How many threads are currently running in my thread pool? The trace, actually not the trace, a span, is a pretty similar concept when at the beginning of some processing you record the time of that processing, and when it finishes you say, okay, it finished. It's like, I don't know, 10 o'clock and it just finished. And what's the status of that? Like, did I succeed? Logs, I'm assuming pretty much everybody knows about logs, like you've done it probably when you shouldn't have. And each of these can be assigned with some metadata, and that's the basic of observability. Thank you. No, but seriously, if you haven't seen like what trace, like full trace looks like, because like again, I don't know how advanced you are. All of these tiny little thingies, these are called spans, and they can come from different places in your, like especially if you have software stack that is microservice based, and at some point, some sort of platform will reassemble that to tell you where it is. I don't know what's happening with this flickering. Where it is that your application spent particular amount of time. Pretty good for debugging. So Opentelemetry data model, as it like what's on the belt, what is flowing through our factory. The one thing that I definitely don't like about Opentelemetry is the documentation. It absolutely sucks. So if you want to figure out and understand what is kind of happening within the Opentelemetry collector, what's with the... I think we have some problem because it did not refresh. Should I reconnect? No właśnie się nie zmieniło. Dobra, spróbujmy tak. Yeah, we have a tiny technical problem. We'll fix it. We detected the problem in production. Right now, our customer base sees that. We don't. Spoko. Dobra. Nie spinamy się, wszystko jest dobrze. Yay! So much win. Is it? Oh. Jeszcze raz? When I bought a Mac, they just told me it just works, and I will just, like, unlike Linux. Spoko, spoko. Nie, wszystko dobrze. Najwyżej sobie siądziemy wokół monitora, wokół laptopa. O. Okay, I will just leave it like that. My guess is it should... Should I go full screen again? No, I won't. Okay. Like that? Let's just try that. Yes, thank you. Cool, where was I? Documentation and Opentelemetry data model. If you want to understand how it all works internally, don't go to the documentation, go straight to GitHub. There are two major repositories. One is Opentelemetry Collector and Opentelemetry Collector Contrib. As the name suggests, all the cool stuff lives in Opentelemetry Collector Contrib. Right. So in order to understand data model, we'll go from the top to bottom. We have a resource. And resource, there is a separate entity. There is a special, it's not class in Go. What is it called? Like, anyway, there is an entity called a resource. And it describes you something that is emitting a metric. So that might be a pod. That might be a process. That might be your cluster. That might be your Android device. That might be pretty much whatever. And you associated certain dimension to it, so certain metadata. If you go a little bit lower, there is a scope. So you can think about the scope as like not really necessary, but like one more level of granularity. So this is actually copied from Opentelemetry webpage. And the way to think about it is you can have a single pod or like a single process, and it's your resource, but different packages or like different libraries that are running in your code are going to be in their own scope, which is going to be pretty useful when you start debugging things. And right, at every point, and this is kind of really important to understand because it's a lot of confusion and a lot of debugging happens when kind of we don't think about it. All of this metadata, basically a dict, is attached to every step of the way. So you can have your dimension attached to resource, you can have your dimension attached to scope, like library version, and you can have your metadata also attached to single metric or even one single data point. I have spent numerous hours trying to understand that, trust me. So again, we have resource have scopes. Scopes can have spans. You can have your metrics and data points in your scope, and you can have logs. Important thing is like when processing, you can always go up. So like if you're rewriting your spans, you cannot access your span events, but you can access your scope and resource. If you're processing data points, there's going to be a lot of processing done by the agent, but you can go and see what's the metric, what's the resource, what's the scope, not the other way around. So like if you're only focusing on metric, you won't be able to access anything that is underneath. That will be important. Metrics and data points, I briefly told you what it roughly is. Metric needs to have a name. Metric needs to have a type and temporality. Well, that's pretty much it. And what are the different types of metrics? So one is the counter, and it essentially counts things. Number of requests, number of packets sent, like you count like Count Dracula taught us to in Sesame Street. Important thing to know is that counter can be cumulative or it can be a delta. So just to give you an example, why is it important? By default, Prometheus, when you instrument your code with Prometheus, is going to send you a cumulative counter, meaning I have seen, I don't know, 10,000 packets sent so far, and the next time you ask it, it's going to tell you I have seen 10,010 packets so far, which is kind of obvious, but it doesn't tell you that in the last 10 seconds I have seen only 10 packets arriving. So usually the platforms will try to figure it out, unless you're using the vendor that I'm not going to name, which doesn't, and you're screwed. So you will have to kind of process that on the agent level. Gauge is like a gauge, like when you're driving a car, it's not that you're counting how many revolutions per second did you have so far. It's just kind of, I'm currently driving at 6,000 revolutions per minute, and my car is hating me for that. Histograms, they detect if you have a certain distribution, like latency of requests served so far, you won't be able to send the latency of each and every one of these. This is why you aggregate that into a histogram or exponential histogram. Spans, I touched on that already. It records when it started and stopped processing. It records what's the status of that processing, like did my request actually succeed? They have 200 or, I don't know, 500. And it has a kind. Kind is, it's not that it's kind of very gentle and good to work with. It's what kind of span do I have? I can have an outgoing span, meaning like a client span. I have an incoming span, like I'm a server and somebody is asking me to do some work. I have I can have internal one, meaning that I can send spans even from within my own application, not just on the boundaries. For example, if you have a very specific function that you want to measure how it's doing, you can send a span at the very, you can measure entrance point to the function and then exit point and send it as a span as well. So that's an internal one. And there's also like producer and consumer if you're working with Kafka. Logs, again, pretty obvious. What you could do with your log is you could attach it to your span, which makes it really, really nice because when you identify a trace that is bad for whatever reason, too long, finished with error, you can already see the logs that were emitted during processing of that particular span. So examples, and why did I tell that it's important to understand the difference between the resource, the metric, and how they all relate to one another. If you have a config like this, when you're trying to filter certain metric, if you were to ask, like, if that wasn't here, and if you wanted to think from the perspective of a metric as you see it on the whatever platform you are using, so your metric, XYZ, would have this dimension, but this dimension isn't attached to a metric, it's attached to a resource in Opentelemetry world. So if it wasn't here, it wouldn't match, your filter wouldn't work. Now that you know that pod name is a resource attribute, you can, from the perspective of a metric, ask, hey, tell me what my resource is, and what's the attribute for that particular value. Same goes with filtering on the data point level. If you want to examine every data point that you have, data point doesn't have a name. Metric does, so you need to ask, hey, I am going to process every data point kind of for the filtering, and tell me if the metric that this data point is associated to is to request, and attribute of this data point and not the metric equal path is missing, then do your action. So pretty important thing to kind of understand that distinction. And pretty quickly, this is how the code itself looks like. So it's pretty much one-to-one mapping on what I said in the config and the code layer. So it's not that clear, but the idea is that first you have resource, then you have scope, then you have metric, and then you go into individual data points, if you choose to write your own processor. Okay, so a very quick recap. We have a resource. It's like a pod or a cluster or a process. It has scopes. Scope is like a library or a package or whatever you choose it to be that will kind of help you cut and slice a little bit more. Scope can have metric, spans, and logs. Metric have data points. Span have span events. You can only access them in a config in the upward direction. Cool, so now that we know what's in the belt, let's get the factory going and let's build a little bit more complex structures. And the way we will be doing that is we will be constructing, I don't like the quality of that. We will be constructing pipelines that will process these entities that I told you about. So again, stolen. The way it works is we are going to be building these parallel collections of different processors that are on the code level in Opentelemetry pretty tightly attached. So basically the entire pipeline is being built on the during runtime using the config that you provide to it, and it's going to basically hand off the data that it has just processed to the next one and the next one and the next one until we just send it away. So if you want to have a pipeline, you need the source of the data, and these are called receivers. You need some processing capabilities, which is processor, and you need a way to send the data out, which is an exporter. There's also some other components. I may have enough time to touch on that, but important thing is that we build our pipelines for each telemetry data separately. So we don't process traces and send out metrics because that would screw up the entire pipeline. We kind of process each of the telemetry, each major telemetry kind separately. Like, I don't know about you, but like exporters, processors, receivers, like pretty boring names in my book. Anyway, how do we do that in the config? So I don't know about you, but like when I first started working with Opentelemetry, I basically received a Helm chart from Splunk at that point, I believe, which was basically install it and don't ask questions, which I did, and then I started asking questions. So the way that we do that is we have to first define all of our receivers, all of our processors, all of our exporters. The 3 dots over here is config. I just kind of assume that you don't need all of the details. And the way that is kind of also nice to remember is when you have a Datadog, it's called Datadog exporter, and it actually identifies a piece of code. If you have, I don't know, OpenCensus receiver, there will be some component, some module, Go module called OpenCensus receiver. So if at some point you want to use multiple filter processors, this is how you make it happen. So you say filter / some unique name, but it's still going to refer to the entity, to the Go module called filter processor. Right. And then you build your pipelines. So the order of this doesn't really matter, but you do notice that it's not a map, it's an array. And it's important for a processor because like each of these will be built into a pipeline. So like first we have memory limiter, then we batch all of our data together, and then we start processing it. 20 minutes. Okay. Receivers. This is, again, I think pretty powerful tool in terms of Opentelemetry because it's a first bridge. So whatever you get the data from, if, I don't know, you've been using SignalFX so far, and you have a lot of instrumentation built into your code using SignalFX libraries, and you just don't want that effort to go to waste, you just set up the SignalFX receiver, and whatever data you've been sending in SignalFX format, after this receiver will be converted into OTLP format, Opentelemetry protocol format, yes. So whatever source of data you have, you can scrap your open source services if you're running Elasticsearch, Mongo, whatever. That's the source of data. You can scrape files, you can scrape syslog, you can scrape information from AWS, from Azure, from Kubernetes. Basically, if you have some sort of data and there isn't a receiver written yet, just go contribute to this whole environment, and we'll have one other source of data that after receiver will have the Opentelemetry format. And then you have exporters. And again, this is the moment that the conversion is being made to some proprietary format of some of the platform that you're probably using. Oh, and one thing I forgot. One of the exporters that we have is called logging exporter, and that's the primary tool that you're going to be using to debug your pipelines and debug your flow. Because at the very end, you will just dump all of your telemetry into standard output and see if all of the processors that you have put together actually make sense or not. And we have processors. And this is kind of where most of the magic of Opentelemetry happens, depending on how you put it together. So I promised some magic. So I'll tell you some spells that I did cast using Opentelemetry. So just to give you some context, I know it was hacky, okay? Don't judge me. But we needed a way to extract information. Basically, we wanted to extract public, it's called public key, but it's basically a UID from the URL that we were able to collect at Istio level. Istio by itself is absolutely great. It gives you a lot of like both traces and metrics. And yeah, data was there. We just needed to expose this path. Like for every request, we will kind of collect the path in Istio. The problem was that if we were to do that, we would basically go bankrupt with cardinality of the data that we would be sending to providers that should not be named. So we only needed the path. We basically wanted to count for this particular UUID, how many 200s, how many 400s, how many requests did we have. We didn't care about the host, we didn't care about anything, just this data. And at the same time, like we wanted our original Istio metric back, because if you change this, like if you put another dimension in your Istio, Istio will be happy to generate you a shit ton of metrics, but like I wanted the original metric back because I had it in my dashboard, and I actually calculated SLOs for my teams using that. So how do I do that? Well, I make a change to Istio to expose this request URL path. As you can imagine, incredibly high cardinality. Then I'm going to copy this metric. I'm going to fix the original Istio request total metric, and I'm going to do some magic into the metric that I have just duplicated. So the way I do that is this. I chained a bunch of processors together. So first of all, I am going to copy a metric pretty much one-to-one from Istio request total to new Istio request. It was named differently, but like let's call it new Istio request for now. Then I am going to fix the original metric. And if you notice the orange thingy like at the very top, that's the same processor. Metric transform new Istio copy. That's the same processor. It's just like it gives you a list of functions to apply, like one by other. So like even within a single processor, you can have like multiple directives. So this basically tells me, hey, the thing that I did with exposing URL path, I don't want it. I only want these labels over here, and I don't really care about request URL path anymore. Please reaggregate all of this data based on these labels. And this is how I got my original Istio request total metric back. Step 4 is I want to process this metric. So whenever I have a URL, it's going to have some path at the very front, then there's going to be a slash, and then there's going to be a UID, which I call public key over here. But I also want to filter the metrics that don't really follow that convention. So the way I do that is, at first, I am going to insert a new attribute called path. I am going to set the value to missing, and then I'm going to process, I mean, using this regex, nothing ever went wrong with using regular expressions. If you match exactly this, then the path is going to be extracted and added as an attribute, so will public key. And the last step of that is, if I have this metric, this new Istio request, and the attribute path is missing, meaning I didn't match on this regex, just drop it. And this is exactly, oh, right, and the reaggregation. So now I had this metric with incredible cardinality. I wanted to reaggregate it back. I didn't care which Istio pod did it come from. I didn't care what OS was there. I only wanted to know, like, what is this public key value, and I wanted to know what the path is, and region and some other minor dimension. So as the result, I know it was like a lot, but we had a metric that was having an incredibly good cardinality. Like I could have pretty much one dimension per unique public key, which wasn't really that big, kind of reaching like 1,000 separate metrics. I extracted exactly the data that I wanted to, and I could start plotting graphs using that. And the original metric was left intact. The only thing that we had to do is restart Istio every couple of hours, which was fine. Again, it was a little bit hacky, and that's kind of the problem with seeing a lot of individual URL request paths that were just kind of seen once. But even though you saw it once, Istio would keep sending you the data about this metric, about this path that you only saw once. Wasn't that big of a problem. We achieved what we wanted to, added another layer of protection. So what are other processors that we could use? That's kind of a very quick introduction to another spell in a second. So you can have a redaction processor. If at some point you want to redact, I don't know, user passwords, emails, whatever there is a single place that you could kind of configure that and you're done. There is the, say, cumulative to delta processor. That was the one that I had to use with provider that needs not to be named to change the cumulative metric into the one that only showed me the difference to the previous one. It's stateful. Resource detection. So if you look at your config, you probably already have that. If you're using Opentelemetry, especially kind of presented to you by some vendor, it's just going to ask a bunch of questions about like, hey, what's the node? What's the, I don't know, cloud platform? What's the availability zone? And we'll just kind of attach that information to either to resource or to your data points. I mean, in this case, it would be to the resource. Cool. So Magick Opentelemetry spell number 2, and this is kind of sorting out the spans. What I really wanted is start ingesting Istio spans, because it would give me a lot of visibility, especially into services that haven't instrumented their code with APM, with spans yet. The problem is that, as far as I remember, at least a year ago, Istio didn't support Opentelemetry directly. It did support OpenCensus, but not OpenTelemetry. Luckily, if you're using the W3C header propagation, they roughly match. It's just like they don't really align on specific conventions. And the problem that it caused is I had a service that sometimes had errors. And if the errors were reported from Istio, it would be a different entity from the service that was actually causing the errors and sending all of the spans by itself. Like basically my service map was just kind of in a completely disarray, like 3-4 times the entities that were there. So what I only needed to do once I read through the documentation is this. I need to set service name properly that Istio wasn't doing for me. I need to set the peer service attribute properly, which again, Istio wasn't doing for me. And I need to send the span kind to a client, span kind client, for all the spans that were kind of originating from Istio gateway and going into specific service. And again, pretty easy. This is the transform processor for traces. Again, have a look at the context that at some point we can be working with the resource, and it's a completely different set of attributes to when we are working with individual spans. Everything else is pretty, I hope, self-explanatory, but basically we are fixing the name of the attribute from service to service name, and we are fixing the peer service over here. And again, a little bit hacky. If I know that this is the same process as parent span, like originating from the same place, it's probably outgoing. If it, again, some hacky, I know. But it worked. So how did we know all of this? How did we know where to look for information? How did we figure all of this magic and made the observability of our platform a little bit better? We didn't. Like, it was trial and error. As I told you, Opentelemetry documentation really sucks, and it was kind of reading through the code or reading through the readmes. And again, if I want to leave you with kind of one thing, is kind of remember your data model. Remember that, like, when you're struggling to understand what the Opentelemetry is doing, why is it not filtering, why is it not processing the data that you want it to, it's probably that the attribute you are looking for is in a completely different kind of place in the tree, and you probably need to find where exactly. So in this case, for instance, well, the hell are you? Yes, I completely didn't anticipate that the extracted value of path is going to live on data point level and not on the metric level. That was a shock to me. How did I find out? I did find out because at some point I did use logging exporter. I dumped the content of like what was in memory, like what was going through the pipeline, and then I realized that, hey, this attribute is not where it's supposed to be. That's how I did that. And again, if in one other thing that you could use to debug is the enable zpages extension. It will basically open another port in your Opentelemetry collector that you could get information that you don't even get in the really detailed logs. So again, that hopefully will help you. So config recap, and I think I'm also running out of time. It's extremely configurable, it's extremely powerful. Just like with Factorio, you can build chain a bunch of assemblers together, put the whole pipeline of data from one place to another, do incredible magic with it. And again, if there isn't a processor that you like, or there isn't an exporter or importer, receiver, sorry, just write one. It's really not that difficult. I did that. Like at some point, I needed a way of converting histogram into metrics, just kind of aggregated on P50, P75, P90 level, and that's all the data that I need. I just wrote it, and it took me a week probably. It's kind of open sourced. Don't judge me for that code, okay? But like it's there. Very quick thing. If at some point you really want to work with different data types, like mix it a little bit together, imagine, for instance, that, I don't know, you want to write your own log matrices, is that the word? You want to create metrics out of your logs in any way. Like, for instance, you want to count how many times they see an error, or debug or info in my logs, you could do that. And the way to connect that is using connectors. So at some point, it's going to act as a sink for, well, logs, for instance, or traces. And the same entity is going to be a, what's the opposite of sink? Faucet? Source of data for metric pipelines, and kind of go through the whole processing list again. So I think that's it. If you have any questions, now's the time.